Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Ashraf bin Helmi and I am from AS2446B. So the title of my final year project is The Comparative Analysis of Inflammatory Capabilities of Combined Astaxanthin and Tocotrienols in A549 cells and Calu-3 cells. Inflammation is a natural defense mechanism, but when uncontrolled, it can lead to chronic conditions like rheumatoid arthritis and cancer. Astaxanthin, a carotenoid, and tocotrienols, a form of vitamin E, are potent natural antioxidants with anti-inflammatory properties. While studied individually, their combined effect remains underexplored. This study investigates their synergistic potential in two human lung cell lines, A549 cell and Calu-3 cell. Problem statement. Limited research exists on the combined anti-inflammatory effects of astaxanthin and tocotrienols in different cell lines. As for the research questions, how do astaxanthin and tocotrienols can reduce inflammation in Calu-3 cells and also in A549 cells? This study is significant as it explores the combined anti-inflammatory potential of astaxanthin and tocotrienols, two powerful natural antioxidants. By examining their effects on A549 and Calu-3 cells, we aim to uncover the molecular mechanism and pathways involved in reducing inflammation. The findings could pave the way for developing safer, more effective natural therapies for inflammation-related illness, providing alternatives to synthetic drugs. Ultimately, this research holds the potential to improve medical treatments, support pharmaceutical advancements, and make anti-inflammatory solutions more accessible and affordable. The objective of the study is to determine inflammatory reduction capabilities of combined astaxanthin and tocotrienols in Calu-3 cells and A549 cells. In this study, we begin by retrieving and culturing A549 cells and Calu-3 cells, ensuring optimal growth conditions to mimic inflammatory environments. Astaxanthin was extracted from Haemococcus pluvialis microalgae, while tocotrienols were extracted from the palm oil to obtain the tocotrienol-rich fraction. These compounds were combined in various ratios to explore their synergistic effects. The prepared solution were then used to treat the cell, laying the foundation for evaluating their anti-inflammatory and cytoprotective properties through detailed analysis. The experimental methods included several key steps. Firstly, combination of astaxanthin and tocotrienols were prepared in specific ratios and applied to A549 and Calu-3 cells to evaluate their anti-inflammatory effects. The primary focus was on markers such as nitric oxide production, which is a critical indicator of inflammation. Then RNA extraction was conducted to isolate genetic material, followed by RT-PCR to analyze the expression of key inflammatory genes. Statistical analysis using ANOVA helped determine the significance and reliability of the result. This comprehensive methodology allowed us to explore not only the individual effects of this compound, but also their potential synergistic interaction in reducing inflammation and maintaining cell viability. At 24, 48, and 72 hours, cell viability of A549 cell treated with astaxanthin showed a consistent dose-dependent trend. At 24 hours, viability ranged from 95.50% at 1 microgram per milliliter to 98.50% at 25 microgram milliliter. By 48 hours, the values remained stable from 95.30% to 85.50%, showing sustained protection. At 72 hours, the trend continued with viability reaching 98.60% at the highest concentration. These results demonstrate that astaxanthin effectively maintains high cell viability over time, highlighting its protective effects even under inflammatory conditions. The consistent outcome across time points emphasize its potential as a safe and effective anti-inflammatory agent. At 24, 48, and 72 hours, cell viability of Calu-3 cells treated with astaxanthin exhibit a stable dose-dependent response. At 24 hours, viability ranged from 95.30% at 1 microgram per milliliter to 98.50% at 25 microgram per milliliter, showing excellent cytoprotective effects. By 48 hours, the trend remained consistent, with viability ranging from 95.25% to 98.50%. At 72 hours, cell viability was maintained, reaching a peak of 98.60% at the highest concentration. This result highlights astaxanthin's ability to sustain cell viability across time points, demonstrating its effectiveness in protecting Calu-3 cells under inflammatory conditions while maintaining its stability and safety. At 24, 48, and 72 hours, cell viability of A549 cell treated with tocotrienols demonstrated a consistent dose-dependent trend. At 24 hours, cell viability ranged from 95.10% at 1 microgram per milliliter to 98.60% at 25 microgram per milliliter, indicating strong cytoprotective effects. By 48 hours, similar results were observed, with viability ranging from 95.30% to 98.50%. At 72 hours, viability remained high, ranging from 95.20% to 98.60% with the highest value recorded at the maximum concentration. These findings highlight tocotrienols' sustained ability to preserve cell viability over time, showcasing its potential as a reliable anti-inflammatory agent. At 24, 48, and 72 hours, cell viability of Calu-3 cell treated with tocotrienols showed a stable and dose-dependent response. At 24 hours, viability ranged from 95.40% at 1 microgram per milliliter to 98.70% at 25 microgram per milliliter, demonstrating strong protective effects. By 48 hours, the trend persisted with viability ranging from 95.30% to 98.70%. At 72 hours, viability remained consistent, ranging from 95.22% to 98.70% with the highest value recorded at the maximum concentration. This result emphasized tocotrienols' ability to maintain high cell viability across all time points, underlining its effectiveness as a natural anti-inflammatory compound. At 24, 48, and 72 hours, the combination of astaxanthin and tocotrienol demonstrated a synergistic effect in maintaining cell viability in A549 cells. At 24 hours, cell viability ranged from 83.30% to 88.70% with the highest viability observed at a 2 to 1 to 5 ratio. By 48 hours, viability remained high, ranging from 83.30% to 88.05% with a consistent protective effect. At 72 hours, cell viability ranged from 82.59% to 87.80% with optimal result achieved at the 4 to 2 to 5 ratio. These findings highlight the combination ability to sustain cell health under inflammatory conditions, offering potential for effective anti-inflammatory therapies. At 24, 48, and 72 hours, the combination of astaxanthin and tocotrienol effectively maintained cell viability in Calu-3 cells. At 24 hours, viability ranged from 80.04% to 85.37%, with the highest recorded at the 1 to 2 to 20 ratio. By 48 hours, cell viability ranged from 82.60% to 86.13%, with the ratio 2.1.5 ratio showing the strongest effect. At 72 hours, viability was consistent, ranging from 81.60% to 85.37%, with the 4 to 2 to 5 ratio achieving the highest value. The result underscored the potential of this combination to provide sustained cell protection, making it a promising candidate for anti-inflammatory therapies. This research successfully achieved its objective of assessing the anti-inflammatory capabilities of combined astaxanthin and tocotrienols in A549 cells and Calu-3 cell lines. Based on the result and discussion, astaxanthin appeared to exhibit a slightly more pronounced effect in reducing nitric oxide production and maintaining the cell viability, especially in the early phase of the treatment. Combined astaxanthin and tocotrienols demonstrated significant anti-inflammatory effects by reducing nitric oxide production in those two cells, while maintaining high cell viability. The dose-dependent and synergistic interaction highlight their potential in managing inflammation-related conditions as safer alternative to synthetic drugs. To advance this research, we recommend exploring molecular pathway in like NFKB and MAPK, studying long-term effect in vivo, and expanding to other cell lines and disease models. Also, optimizing formulation to improve clinical efficacy and bioavailability. Together, these steps can pave the way for novel, natural anti-inflammatory therapies. Last but not least, these are some of the references that provided in the study. That's all from me. Thank you and Assalamualaikum.